This conference
That
will
is the
now be
reason
recorded.
why we had given a long break, 1 week, 2 weeks, or maybe many cases 3 weeks break, so that you could redo the entire assignments. Some of you have attended interviews probably, or some of you are yet to attend. Those who have attended the interviews, they would tell you that any interview they go, the focus is on the depth of one topic rather than how many topics you know. One topic, let's say SV, how much depth you know. AXI, how much depth you know. Rather than saying I know AXI, I know 10 protocols, I know one protocol, I'm expert in one protocol. That is what industry expects, because what is that indicates to the person, he knows that if you can learn one thing in depth, you can learn remaining 9 things also in the same depth. Okay, so let's jump into the AXI protocol. Okay, from now it will be continuous, no breaks. AXI will complete 2 3 days break, will immediately start the project. The break was to give you time to pick up SVUVM concepts so that you are ready for this project. Okay, if you are not good with SVUVM, please redo the SVUVM, that will be very good for you. Okay, so let's start with the AXI protocol. 1 second. Just please read this once. This is the agenda of the training. There are 2 pages agenda overall. First read the first one. Just let me. Even here, except for this, till this point, all the black ones are protocol specific only. Okay. The red one is what is focused on test bench development of the AXI. Okay. First, let us start off with. No, this is not meant for Verilog people. Those who have completed SV and UVM, it is meant for that. Or if someone has completed SV, also it's meant. Okay. I think Minu, you should not be joining. I think we have ended that session already. Okay. Your next session will be at 4 p.m. lab session. So let us start with protocol overview. First, what is a protocol? Protocol is basically a set of rules for the various phases of transfer between master and slave components. There is a master, there is a slave. How the various phases of transfer happen between master and slave is called as the protocol, those guidelines. Protocols are basically two categories. Whatever protocols you learn, SPI, I2C, UART, APB, AXI, AHB, all these protocols are basically two types. One is on-chip protocols, one is peripheral protocols. On-chip protocols examples are what? APB, AXI, AHB, OCP, PCI. These are all examples of on-chip protocols. What is about them? They are limited by the frequency of operation. Whereas, and the data communication in on-chip protocol happens in terms of transaction. See, when we take APB in SV, system verilog UVM, what is the term we used? APB transaction. When we took Ethernet, what did we use? Ethernet packet or Ethernet frame. So Ethernet is a serial communication protocol or peripheral communication protocol. There we use the term frame or packet. In on-chip, we always use the term transaction. Okay. So data communication happens in terms of transactions. What all phases are there in on-chip? There could be various phases like arbitration phase, address phase. The overall protocol itself can be called as arbitration phase, address phase, data phase, response phase. And there is something called as handshaking. It is done using dedicated signals. APB, which signals are used for handshaking purpose? Can you tell me? Okay. One second. Please read the peripheral protocols once. So I hope you have gone through it. There is handshaking is done using dedicated signal. What are the dedicated signal? Like in APB, enable and ready. So like that, every protocol will have a set of dedicated signals for handshaking purpose. When it comes to peripheral protocols, what are the examples of peripheral protocols? USB, PCI Express, SATA, SPI, I2C, UART, HDMI, VGA. What is unique? What is that? Is how do you correlate all these protocols? These are the things you see every day. Okay, anyone who is not familiar with electronics, also VLSI, also they will know these protocols. I mean, your friend who works into software will know what is VGA protocol is. VGA port, what is HDMI port. So anything that you see outside of an electronic product is a peripheral protocol because it is used to connect the periphery. At the peripheral, connections will happen. On chip means what? They happen inside the chip. What is the thing with peripheral protocols? They are limited by the number of ports, because imagine how many ports are there in USB. 4 lines are there. If you open, if it is high speed, 4 lines. If it is super speed, 9 lines will be there. Imagine having 50 ports of USB. My whole USB port will be one side of laptop. If USB has 50 copper wires, it will take one side of the entire laptop. Okay, so we cannot do that, right? If we keep one side whole for USB, then what about other ports? Hence, they are always limited by the number of ports. And data communication happens in terms of packets or frames. And handshaking happens using preamble or sync. There will be something called as preamble or sync. We first send the sync pattern. That's the indication to the other side that packet is coming. It's like if I connect pen drive into my laptop. The first information goes from my laptop to pen drive is the synchronization pattern. Sometimes it's called as preamble, like that. So that's the indication to my pen drive that some packet is coming, and it will automatically start collecting the information. So receiving device uses preamble or sync pattern to start packet detection. How do we do protocol differentiation? Basically, protocol differentiation is done based on 4 factors. One is performance, one is the power consumption, one is the features supported, one is the pin count, and the cost of implementation. There are 4 factors that decide. It's like very simple. Forget this also. You want to purchase a laptop. What are the things you keep in mind? Performance, the cost, power consumption. What else? The area. I mean, how much will be the area of the laptop, right? There are few such factors. Even in protocols, when you have to choose a protocol for your specific uses, you will choose with these 4 criteria. What is the performance? What is the power consumption? What is the feature supported? How many features does it support? And what is the pin count and the cost? We always want performance to be higher side, power consumption to be lower side, features to be on a higher side, pin count and cost should be lower side. So we cannot get best out of everything. From one system, we cannot get best. Let's say if you try to get these things best, cost will go up. Somewhere, some things goes up. Okay. First, one of the things we are talking about, what? Features. What features are supported? Okay. AXI supports, different protocols supports different features, like out of order transactions, overlapping transactions, cacheable transactions, bufferable transactions, wrapping transactions, incrementing transactions, locked transactions, like that. Various features are there. Let's not go deep into each of these things, because even if I explain them, you won't remember as of today. Just remember that AXI supports most of these features, whatever except for these things. Everything AXI supports, because it supports more features, it fits into more requirements. Since it supports more features, it fits into more requirements. APB, if you take APB, the one you learned in Verilog or System Verilog, it only supports this feature. That's only 1 or 2 features it supports. So that is the limitation of APB. Whereas when you go to AXI, it's a high performance protocol. Let us start off with understanding some basics of the protocol. AMBA protocol basics. AMBA stands for this one, Advanced Microcontroller Bus Architecture. There are various types of AMBA protocols: APB, ASB, ATB, AHB, AXI, ACE, CHI. This is the most complex protocol. In the AMBA family, what is AMBA stands for? Advanced Microcontroller Bus Architecture. It consists of almost 7-8 different protocols. Okay, it's like a family having different people, right? So everyone is not same, right? So like that, APB is not same as AXI. AXI is not same as ACE. ACE is not same as a CHI protocol. But who is most complex in this protocol? CHI. Who is the most simplest? APB. So that's where we started our training with APB protocol. Okay. As you go in this direction, the arrow direction, the performance increase. I mean, they are meant for high performance and those things. This gives you lowest performance. Power consumption also will increase because to support more features, it needs more signals. With more signals, more power consumption will happen. Cost and complexity also increases. So if you want a design, so how will you select which protocol to use? Somewhere for you, low performance is the okay. You are okay with low performance as long as power consumption is less, cost is less. APV. Okay. It's a very rough idea. Okay, I mean there are times where you have to use CHI protocol only. For example, going forward, you will come across some term called as cache coherency. Come across term called as cache coherency means in very simple terms maintaining all the caches to be uniform. The content in the all caches L1 L2 caches will be there in a laptop in a system. We need to maintain the same data in all the caches for a location. Let's say address 100 is there, all of them should have a same data for address 100 in the caches. That concept is called as cache coherency. None of these protocols can do that. They don't have that concept at all to get the cache coherency supported. So only protocol that supports is to ACE and CHI. So we have to use ACE and CHI. Let's say I want to do out of order transactions. Out of order transaction means what? Request goes in one order, responses come in a different order. That is out of order, right? If they come in the same order, then it is in order. What is other side? Out of order means what? Request goes in one direction, one way, one order. Responses come in the different order. That is called as out of order. So okay. Now I hope I'm audible. Okay. Okay. Let's understand where these AMBA protocols are used. AMBA protocols are very important. Okay. Let's understand what is the hierarchy where AMBA protocols fit in and why those AMBA protocols are very important for you. Any electronic product, every electronic product you're using, anything you're using, mobile phone or even a remote, anything, right? Most invariably, it will have either a processor, right, microcontroller inside. It could be even a projector, it could be the mobile phone, it could be the laptop, anything you're using, washing machine, microwave oven, even a car. Inside the car also there will be a microcontroller. So there will be either processor or microcontroller inside it. These processors and microcontrollers are developed using two types of architectures. What are the two types of architectures? RISC and CISC architectures. I mean, there was a time where people used to discuss which is good, which is bad. Now, pretty much many people agree that RISC is the better among them. After so many millions of products being manufactured, mobile phones, everything being manufactured, we can kind of say that RISC is the better architecture. They are too different. Okay, they are too different. But if you start comparing them, who is good? RISC is a better architecture. Okay. Like you are using Intel laptop, for example, that's based on CISC architecture. Actually, laptop I'm using it has got Intel processor. It is based on the CISC architecture. I'm using mobile phone. It has got a processor. It is based on the RISC architecture. Okay. So let's not get into what is RISC, what is CISC. RISC is what? Reduced instruction set. CISC is what? Complex instruction set. So reduced instruction set means the instructions are much simpler. Complex instruction set means what? Instructions are complex. One instruction does many things. Okay. RISC itself, currently there are multiple companies who manufacture RISC processors. ARM, who else? RISC 5. RISC 5 is the architecture name. There may be another one or two. CISC is again, let's say Intel, AMD. If you see, a lot of products that sell are based on the RISC. In all those things, ARM will have 95% market share. Means what? Any mobile phone you buy, there is a 95% chance that it has got a ARM processor. Means even if you are traveling in a car, there is an electronic system, 95% chance that it has got an ARM processor inside it. You are using a washing machine, it has got a RISC-based microcontroller or processor, 95% chance that it is an ARM processor. So that is the importance of ARM in the architecture. Right now, what is happening? RISC 5 is coming up, but it will take a decade time for RISC 5 to do anything significant, because ARM ecosystem is so strong. It's like Apple ecosystem. What does Apple ecosystem means? What they have everything. They buy, they sell product. They have Apple Play Store. Lot of things come as one package, right? So where you cannot go out of Apple once you purchase that mobile. Same way, ARM is such that so many resources are there, which they have already developed. For anyone to compete with that ecosystem, it takes a lot of time. So RISC 5 will take at least 5-10 years for anywhere to start competing with ARM. So for near future, it's the ARM which is going to have a bigger market share. All ARM processors, external interfacing, when they interface with the external world, they will do only using two interfaces, either AXI. Anytime, let's say if this is ARM processor, I want to talk to the external world. It only happens through two protocols, AXI protocol or AHB protocol. Then you may say, what is CHI protocol, CHI, what is ACE protocol? ACE is internal to the processor subsystem. ATB, advanced trace bus, is also internal to the processor subsystem. ACE, advanced coherency extension, AXI coherency extension or something. It is also internal to the processor subsystem. But what talks to the outside world? Let's say this is USB controller. This is ARM processor. How do they interface with each other? Either through AXI protocol or AHB protocol. There are only two protocols through which they interface with each other. And most of the time when you get into any project, you don't debug into the processor. You don't debug into the processor subsystem. You don't debug because it's already proven, very much proven. You will only be debugging how it interfaces with the other component, how it connects with the other components. So which protocols you should be comfortable with? AXI and AHB. Understand my point, right? If this is my processor subsystem, inside this we will use ACE protocol. Inside this we will use CHI protocol, CHI. CHI means what? CHI. Inside this we will use ATB protocol. So inside this processor subsystem, what we use is those protocols. But anytime you want to talk to the external world, it is always two types, AXI and AHB. Then APB, where does APB come? We'll discuss later. APB is the next level, down next level. Let's say somewhere here you are connecting something, here you can use APB protocol to connect low performance peripherals. into this architecture, I want to connect a low performance component, that I connect through APB. So hence our emphasis will be on learning AXI and AHB APB. Earlier we used to teach AXI and AHB, APB anyway we used to teach. Now we are skipping AHB altogether, because what is happening is people are not able to come up to the level. I mean, after AXI, what happens is, if I ask what is handshaking, also 70% people don't know how to answer. Okay, I ask what is out of order transaction, people don't know what to answer. I ask draw a simple timing diagram in AXI, they don't know how to answer. Then we thought, let's not do too many things, let's only do few things and let's do proper. So you understood the importance, right? How many types of processor architectures are there? Two types, RISC and SIS, all portable applications. Let's say wristwatch. Okay, a lot of new things are coming, right? Anything new product is releasing is a portable only. They are wearing the wearable glasses or something, right? I mean, electronic glasses, right? Even this mobile phone, all these portable things will be always based on the RISC only, because RISC gives the lowest power consumption, gives a relative high performance. At low power consumption gives a relatively very high power consumption. CISC is not like that. They consume very high power, but they'll give high performance. RISC is giving that advantage of better performance, but with low power consumption. That is what you need for a portable application. Mobile phone is a portable application. You don't want it to drain out in half an hour, right? In laptop it's fine, or even in desktop it's fine, because it is always powered by the external power. Okay, so that's the same thing we are explaining. Where these protocols are used, AX and HB are used in ARM processor interfaces face with external world. With external world. External world means what? External components. All ARM processors are RISC based. ARM has three types of families, three types of processor families. ARM family has three types of processors. One is called as A series. A stands for what? Application series. One is called as M series, which stands for embedded series. R stands for real time. Application is one which is used in your mobile phones. Application processors are very high performance processors. Mobile phone, those kind of things. Because why mobile phone? Like when the data is coming, it processes the command information. Everything, all the things. Let's say you are using WhatsApp. Where is that whole information is getting processed and all that? Processor only. Finally, it's a hardware which is doing everything, right? If any application you open, let's say Google Pay, Phone Pay, or any WhatsApp, everything, right? It happens finally on the processor only, right? So for that you need high performance processors. AXI is used as AXI is used for as processor interface to rest of the system. M series is what? It's a medium performance processors. Like example is washing machine, microwave oven. All these are examples of M series where AXI is used. If you want very high performance, you go for AXI. Medium performance, you go for AHB. Third series is what? R series, real time series. R stands for what? Real time. And safety critical application process. The best example is the auto driven cars. There it collects the information on the fly and it processes the information with a high priority and it takes the further decision. In all those things, they will use R series processor. That's why it's called as real time. Here also AHB is used. Automotive applications where data needs to be processed in real time. This is a brief about AMBA protocols. So how many types of processors are there in ARM series? ARM series. Three. What is the first one? A series, which is application series. One is M series, which is embedded series. Means all those embedded applications they go, right? All those things. What is the last one? Real time. R series is the real time ones. Okay. Name itself will come like that. If you go to the if you open mobile phone spec, they will say Cortex A53. A is there for application series. If you buy a microwave oven, they will say M series, M33, M34. The processor itself will be M, means it's an embedded application. If you open your car, any auto driven car, or any, not even that, there would be other applications where electronics is required in every car. There they would have used probably R series or maybe M series sometimes, right? Okay, so first let's start with again AMBA protocol basics only. Okay, first, how do we differentiate the protocols? One of the things was based on the performance. What is meant by performance? Yeah, basically in a given amount of time, that is in the number of given clock cycles, how much maximum data that can be transferred in a given amount of time, how much maximum data can be transferred is the performance, right? More you can transfer, better is the performance. Lower you transfer, lower is the performance. If I start with APB protocol, it gives me the lowest performance. Why does it give lowest performance? Let's try to understand. In APB, each transaction, just go back to APB diagram. Let's take APB. This is a diagram. Okay. At what edge the transaction is starting? Tell me. T1 it's starting. At what time it's completing? Okay, you forget T1 also, at least T2 it's starting, because T2 edge is where everything got applied. Where is it completing? T3. When can I apply a new transaction? At what time can I apply a next transaction? Only T4, right? Not before that. Only here I can apply a next transaction. That means one transaction is taking how many clock cycles at minimum? Minimum 2 clock cycles. So it is taking T2 and T3. Only after that you can do a new transaction. So that means in APB, minimum it requires 2 clock cycles to do any transaction. That is what is. Each transaction requires at least 2 clock cycles. Assume that PW data is there. It is 32-bit width. How much bus width? 32-bit width. I want to transfer. It's bits, okay. How many bytes is it? 4 bytes. From master to slave, I want to send 100 bytes. How many clock cycles will it take? Can you please do that calculation? Using APB protocol, to send 100 bytes, how many clock cycles is it going to take? Please do that calculation, everyone.
Hi Arjun.
Yeah. Can you please tell me how many clock cycles it will take? 50 clock cycles, right? You have got that calculation. Okay. So everyone, I hope you have understood that. It will take 50 clock cycles to transfer. That is using APB. When it comes to AHB, AHB uses a concept called as pipeline. There is a concept called as pipeline. Tell me, going back to this diagram. Yes. What is that we could have done to improve this protocol performance? What we could do is, while this address phase is happening, see, for this address phase, this is where the data phase is happening. Do you agree with that? For the address phase that happened in T2, at what time data phase is happening? T3. And when is the next address phase will happen in APB? T4, at least T4, right? What is done in AHB protocol is, you do the address phase for the next transaction here itself. Corresponding data phase will happen at the T4. Effectively here, because they're overlapping. It's called as pipelining. Pipelining means what? While previous transaction is handled, you initiate the next transaction parallelly. It's called as pipelining here. Now tell me how many clock cycles will it take going by this to transfer 100 bytes? 25. Actually plus 1. Because first you need to do address space, right? At that address space, there was no data. This data phase was not there. Then only the data phases started happening. So 1 plus 25. So it will take how many clock cycles? 26. Did everyone understood how do we get this 26 clock cycles? Have you understood? So AHB uses concept of pipelining, which ensures the next address space and the address data phase, previous transaction data phase. Happens in the same clock edge. Happens on same clock edge. On AHB uses concept of pipelining, which ensures the next transaction address phase and the previous transaction data phase, okay, which are, I would say, the current transaction. Okay, okay. Uh, Happen in the on the same clock edge. 100 bytes now can be transferred in 100 bytes now can be transferred in 26 clock cycle only. Why 26 clock cycle? In the first clock cycle, you do only the address space because you need to give the address information, right? Only then the data will come in the next clock cycle. So the second clock cycle, you do second transaction address space plus first transaction data phase. In the 26th clock cycle, the 25th data phase will happen, the last data phase. So finally, totally how many clock cycles do you require? 26 clock cycles. So isn't it an improvement? So what is that one thing that AHB is doing to improve the performance? Pipelining concept. So this is how it does. APB doesn't support pipelining. So hence it doesn't give the performance.
To support pipelining, it requires a additional hardware, additional signals actually. See, AHB requires more signals to implement this concept of pipelining. To implement this concept of pipelining at the burst transfers. There is a concept of pipelining and there is a concept of burst transfers. Burst transfer means back-to-back transfers are happening. For both of them, it requires more signals. That is the cost. I mean, what is meant by cost? One, you are getting a high performance. At what cost? By adding more signals and more complexity. Now let's go to AXI. I told you that AXI gives you better performance than HP. Now the next question comes, already whatever improvement we can do, we have done. Right? Can there be anything more than that you can do? Okay. What is that AXI does is, I told you, right? In AHP, here you give the first address, next address, third address. Here the, let's say if it is A1, this is A2, A3. If this is D1, D1 means what? Data 1. This is D2, this is D3, 2, 3. This is what is how it is done in the HP. Do you understand the skewed one cycle gap is there? Because if you issue the address, corresponding data will come in the next clock cycle only. Okay, A2 next clock cycle in the next data will be in the next clock cycle. What AXI does is to reduce the power consumption. It removes them altogether. It only gives the first address. That's it. And ask the slave to do its calculations. Why is it so? I know that if the current address is 100, if I'm sending 4 bytes per clock cycle, each transfer I'm sending 4 clock cycle. In AHB, they will specifically send 104. They'll send 108. Next 100C. Next 110 in hexadecimal. AXI thinks that this is not required. You agree? This is something you can do calculations, right? If the current address happened at 100, if each clock cycle I'm sending 4 bytes, where does the next address should happen? 104. Next transaction should be to 104. The next transaction should be to 108. Next should be to 100C. Next should be to 110. Next should be to 114. The way it is obvious for you and me, the AXI thinks that slave should be intelligent enough to do that calculations. Okay, so it won't send that all. In AHB thinks that the slave is very dumb. AHB thinks what? Slave is dumb. Slave is not smart. So I have to give every information every time. And that is the reality. Reality means what? In AHB systems, AHB slave is dumb. Means it just whatever it gets, it processes that information. It will not do any additional processing. It will not think that okay, now 100 came. Next one should be 108 because 8 bytes came. So 100 plus 8 means what? 108 bytes. So next one should be for 108. It won't do such things. It will blindly do whatever address comes, it will process that. Whereas when you come to AXI, you send out of these 26 transfers, 25, right? How many transfers? 25. Address space is only done once. Remaining 24 times you won't do at all. Why? You assume that second transfer, third transfer, fourth transfer, slave is intelligent enough to make that calculations. So what is the advantage of not sending that information 24 times? Toggles are being saved, right? You don't need to drive the address space multiple times. If you don't drive, what happens? Power consumption is reduced. Performance is same, but power consumption is reduced. Complexity is also less, but slave is getting little more complex. That's okay. Okay. Other than that, AXI has one very powerful concept called as ID, identification signal. There is AXI has one very powerful signal called as identification signal called as ID. Okay, that makes AXI support lot of things. It supports out of order transactions, overlapping transactions, interleaved transactions, lot of things. 3 of them at least, only because it has got a feature called as id, where it identifies each transaction. Whatever transaction it does, it gives one identification number, that all the phases of the transaction will happen with the same identification. Let us take one simple example to understand what is this identification number is. You went to a bank to apply for a loan, home loan. They will give you one application number. Throughout that loan process, you have to use the same application number. Whether you submit a document, whether you they sanction the loan, they will not give it to your name. They will say this application number is sanctioned loan, because name can have many people with same name, right? Srinivas, there can be 10 people who have applied the loan with same name, but application number will be unique. So throughout the transaction, bank will use the application number as the identifier to identify everything. So when I submit document, I will fill application number. So they know that this document is for this transaction, this loan. So next person, let's say one of my friend is sending and submitting, then his application number will be different. So they can identify this document is for a different transaction. AHB doesn't have that concept. APB doesn't have that concept. Because of that, in AXI AHB, multiple transactions cannot happen at the same time. Only one transaction at a time. Whereas in AXI, because there is a concept of ID, at same time, multiple transactions could be happening between master and slave. Like bank example, because application number concept is there, the bank, even if 100 people apply for the loan, they can identify whose loan is what based on that application number. Same is the concept of ID in AXI. AXI removes multiple address phases. Address phase is done only once. Address phase is done only once. Next, AXI slaves are designed intelligent enough to calculate the next address. They're intelligent. AXI slaves are intelligent to calculate the next address automatically. Based on the initial information given to them, they can calculate the next address. And AXI introduces the concept of ID to support multiple concurrent transactions. Okay. Because of ID, they support overlapping transactions. Overlapping means what? While one is happening, you do next transaction. Okay. What is non-overlapping? I'll give you an example. Everyone, please understand this architecture diagram and read that notes once. Just see what do you understand from this diagram. So from that, this diagram, you can understand that this is an example of an SOC diagram. This is where the processors are present. Okay, called as A7, A15. I was telling, right? What series are they? Application series. This would be one of the example that goes into your mobile phone, possibly, right? This is how they are interfacing. You see here, two lines. You see that will be AXI or AHP, mostly AXI. And all these systems they develop, they will also have AXI interface here. AXI protocol will AXI, because this is an AXI interconnect. Interconnect means what? Everything that connecting to it will be AXI interconnect, AXI protocol only. This is one more example where AHP is used, APB is used. See, these are the processors who have AHP protocol, and down to connect low performance protocols, they need APB. So to connect AHP to APB, they use a bridge called as AHP to APB bridge. This whole portion is working on AHP. This is all working on APB. AHB and APB are different protocols actually. To connect both of them, we use something called as a bridge, which converts AHB signals to APB format backwards, APB to AHB. This also does the same thing. Question comes, why do we need APB? Why can't we connect everything with HB only? The cost. See, best example is, let's say they want to manufacture a remote control for TV. Okay, TV remote control doesn't require high performance like USB. The way the data transfers in USB, remote won't require, because in a second, in a minute, you will type, press 5 times or maybe 10 times. So 10 bytes of information going out, let's say. There, the protocol they use, they don't require very high performance protocol. Because of that, they use protocols which are low performance. The TV remote will come for roughly 150 rupees. If you want to purchase a new Airtel remote or any remote, it will cost you only 150 rupees only. Because their primary requirement is not performance, their primary requirement is how cheap it can be done, and it should still perform as per the user requirements. Their primary goal is what? Reducing the cost is the primary goal. So there they purposefully choose a protocol which will reduce the cost of the production. Somewhere else, performance is very important. In some other place, there they will use high performance protocols to make sure that they get performance like that they decide. Okay, because instead of, if the remote was made with a high performance things unwantedly, instead of 150 it will become 500 rupees, then people won't afford that. So accordingly they decide. Okay, this is an example of a SOC diagram. System on chip means what? Everything interconnected to give one system kind of behavior. So let us start off with correlating. 10 minutes will take, then we'll go for a break. Okay, correlating AXI protocol with APB protocol. Why should we correlate AXI with APB protocol? Is because you all know APB protocol. Tell me what all things you know in APB protocol. What all signals are there? P clock, P reset. Can you write down what all protocols, what all signals you know in APB protocol? Yeah, have you written down? So what all things are there? If you would have seen that P clock, P reset, P address, PW data, PR data, P write, P enable, P ready, P sell, P error. Okay. APP implements all write and read transactions in a single channel. It's called as a channel. All these things put together, it's called as a single channel. APP only supports single write, read, error, and aligned transactions. Uh, I think let's not complicate it too much. It will be like this. What about AXI? Can you please read this one? The AXI also requires these signals. Okay, so basically AXI is nothing but APB signals plus the new signals required to support advanced features. The AXI has some advanced features, right, which APB don't have, like overlapping transactions, burst transfers, cacheable transactions. A lot of things you'll come across. To support them, you need a new signaling, right? You need to tell what is that I'm doing. You need for them, you need a new signals. Okay. So simple. AXI is nothing but APB plus new signals. So what is the foundation for learning AXI always? APB. So you should always be good with APB before you learn AXI protocol. So AXI also requires all these signals. It also requires additional signals to support more features. More importantly, AXI implements. In summary, what is that you need to remember is AXI implements write transactions using 3 different channels and read transactions using 2 different channels. Write transactions using 3 different channels, read transactions using 2 different channels. Total channels in AXI is what? 5 channels. Okay. What is the advantage of having different channels? We'll discuss. Let's understand through one example. Uh, the best way to understand the channels is the real life analogy. 25 years back, there used to be only DD channel, Doordarshan channel. Okay. So people didn't had any option. All the information had to be conveyed through DD only. So you didn't even had an option to switch to any other channel. Now what happens is the same cable you get. Let's say, assume, forget setup box, everything. From your antenna, you get same cable. It carries multiple different channels. What is the advantage? Because it carries multiple channels, you are able to do multiple transactions concurrently. Transaction is what? You're watching one movie is a transaction. You're playing some game, you're watching some game show is a next transaction. I mean, different channels you get is a different transactions are happening. Like one transaction is what? Starting a movie, finishing movie after 2 hours is like a one transaction. So all of them are happening independently, right? One time, one, let's say one movie is happening in one channel, it won't tell that since movie is playing you stop the song in the next channel, right? They happen parallelly. That is the advantage of having channels. Now is it better? From a user perspective it is better, right? Having, instead of having one DD channel, we have an option now where multiple channels are part of the same physical lane. It's still a setup box only. It's still the same link only through which you get multiple channels. That is what AXI does actually. APB was like Doordarshan. Only one you can do only one. AXI is like same cable but multiple channels are part of the things. Okay. So there we had a different requirements. In AXI we have a different requirements. So they divide all this into 5 total channels. 3 for write purpose, 2 for read purpose. Let's again remember the fundamentals. What is the purpose of having channels? To able to do concurrently multiple transactions. While one transaction is happening, you don't want other transaction to be stuck. Essentially, that's the purpose. Now, very finer terms we'll understand later. For now, understand that having channels improves the efficiency. Having multiple channels improves the overall transaction efficiency. It helps multiple transactions to happen parallelly. Okay, you understand that point, right? These are the two very important advantages. Multiple transactions and they all can happen parallelly. Here multiple means 3, here multiple means 2. Right?
It's compulsory to having like transaction 3 different channels and read transactions with
Every write transaction is implemented in all the 3 channels. Every read transaction is implemented in the 2 channels. Don't literally understand it like TV example. Don't literally take it as
it is fixed.
it is fixed. It cannot change. Okay. Okay. We'll understand. The TV example is only to understand. See, APP is like only one channel. One wire coming means only one set of signals are coming. In case of other recent ones, what happens? In the same physical lane, multiple informations are being sent as a different channels. Okay. What is AXI Lite? AXI Lite is AXI supports a lot of complex features. Out of order, overlapping, burst transfers, cacheable, bufferable. Some of the applications don't require so many things. They only require APB plus very simple features. Let's say is AXI. It is APB plus burst transfers, overlapping transfers, out of order transfers, cacheable transfers, bufferable transfers, protected transfers, plus locked, plus exclusive, various features. Sometimes you don't want so many things, right? Sometimes you want only this much, only this much. That's called as AXI Lite. This whole thing is the complete AXI. This whole thing would be complete AXI. But many times you don't want to do overlapping transfers, let's say. You don't want to do out of order transfers. You don't want cacheable transfers. You don't want protected transfers. Because you by not having, you will reduce the complexity. You'll reduce the number of signals. So your overall implementation will become simpler. So you only want APP plus burst transfers. This will become AXI Lite. Kind of. I mean, there may be another 1 or 2 things, but Lite is nothing but the cut down version of what is actual AXI is. Because this is a very important. Burst transfers is what improves the efficiency. This brings in different features actually. You understood what is AXI Lite means? Again, I am telling there could be another 1 or 2 things that when we read the AXI Lite spec, we'll get it. What is our focus in this session? What new signals are added to support more features? are required to support the more features. What is the benefit of having 5 different channels? Do you understand what is the benefit of having 5 different channels? Advantage is it allows multiple transactions to happen parallelly. Okay. What are those channels? When you understand, you will be able to, when we go through the channels, you will be able to understand what is, how multiple transactions will happen parallelly. Let us take a break for 10 minutes. Once we meet after 10 minutes, we'll continue with the remaining.
This conference will now be recorded.
Okay. So we were discussing about how AXI correlates with respect to APB. I was telling you that AXI is what? APB plus all the new things. Here, actually speaking, I haven't listed many things. Some few things I haven't listed. Okay, wrapping transactions, incrementing transactions, few things. Okay, I don't want to complicate the things. I just wrote in a simple terms. AXI is nothing but APB plus additional features. To support those additional features, you need additional signals. Okay. For example, in APB, there is a concept of slave selection. For that, what is the signal added? P selection. If P selection is not there, can you do a slave selection? No. So the concept of slave selection is only possible because P cell is there. If P cell is not there, slave selection is not possible. Same way, to support burst transfers, we need an additional signal called as burst, AW burst or AR burst. There is a separate signal is required. To support overlapping out of order transactions, we use ID. I told you, right? ID signal. To support cache, we use a signal called as cache signal. The name of the signal is called as AW cache or AR cache. To support protected transfers, we use a signal called as PROT, PROT. To support locked and exclusive transfers, we use a signal called as lock. The name itself is very much correlates with what you are doing. So those signals is what you see. If I show you the summary of the signals, read now, you'll understand on the left hand side. AW address, AW ID is for write address ID. AW address, AW length. What is the significance of each thing? I'll tell you. For now, don't try to understand everything. Okay. AW size, AW burst, lock, cache, prot, valid and ready. Okay. You may be asking what is AW is? AW is the write specific channel. Similar to read, similarly for read, there AR. AR is for read specific. So basically, the very first thing that AXI does is it separates the entire AXI into 2 different channels. Write specific channels, read specific channels. What is the advantage of that is that writes and reads can be done completely independently. What is mean by independent is you could be watching one channel in some other TV through the same thing. You could watch another channel also. Both can happen concurrently. AXI supports burst transfers. First, let's understand what is meant by burst transfer. It's a very important concept because what is common in AXI Lite? Burst transfer. I told you, right? If I wrote down these things between AXI Lite, AXI and AXI Lite, what is common? Burst transfer is the common thing. See, other things they have ignored, but AXI Lite has compulsorily taken the concept of burst transfer. First, let us understand the term burst transfers. Burst transfer means address given once, address is issued only once, data phase issued multiple times. So the advantage of burst transfer is what? You are utilizing the bus cycles more efficiently. So if you send address space multiple times, and then you're not sending data, right? During the address space you don't send any data. During the address space you only tell what is the address, whether you want to do write or read that information. Where does the actual data transfer will happen? Data phase. So here let's say example, one address space plus 16 data phases. Totally it will take 17 clock cycles. Your effective efficiency is 16 by 17% efficiency. Out of 17 clock cycles, you're using 16 clock cycles for data transfers. Without burst transfers, they are called as let's call it as atomic transfers, for example. Atomic transfers, one address space has only one data phase, no multiple data phases. Next transaction again you have to do one address space. So for transferring 16 total transactions, 16 address spaces, 16 data phases. So what is the transfer efficiency? 16 by 32. Which is more efficient? Burst is more efficient or atomic? Burst is more efficient, right? What is the primary goal of burst is do address space only once, do the data transfers multiple times. When you do the data transfers multiple times, that is data transfers is where the actual data transfers are happening. Address space is only to convey the information at this address. I want to do write or I want to do read. So hence all the high performance protocols like AXI, AHB, they all supports burst transfers. Okay, wherever you come across the term burst transfers, the meaning is simple. Address is issued once, data phase is issued multiple times. I will show you an example to help you understand what is burst transfer. This is an example of a burst transfer. Address space is issued once only. First data phase, second data phase, third data phase, fourth data phase. 4 times data phase is being done. Got it? Had it been atomic transfer, for this next data phase, I should have done address space again. For next data phase, I should have done address space again. For next data phase, I should have done address space again. What it does is it takes more number of clock cycles to do. So this is an example of, this is a concept of burst transfers. AXI supports burst transfers. Address is issued only once, data phase is done multiple times. To support burst transfer, what details master should tell to the slave? What is a burst length? Burst length means what? Okay, I have done one address phase. How many data phases am I going to do? I have done one address phase. Corresponding to that one address phase, how many times I am going to send the data? That is called as burst length. So the number of data transfers in the transaction. Next thing is what? Burst size. Each time, each data phase, how many bytes I'm going to send? How many bytes sent in each transfer? Understand? In each data transfers. That will be better. This is the number of data transfers. This is the number of bytes. Okay. Number of bytes in each data transfers. That is called as burst size. Burst type is the third category. how the data should be stored in the slave memory. Is the burst incrementing type? Is it wrapping type? Is it fixed type? We'll discuss all the three categories. Three types will be there generally. One is incrementing. What is incrementing means? As you write the data, first data transfer, data will be stored here. Next data transfer, data will be stored in the next location. See, address is getting incremented automatically. Next transfers will store here. This is incrementing. You may say this is how it should happen, right? This is how it should be naturally happening, right? Isn't it? Where every address, every data phase, the data should get stored to the next address location. The second category is called as fixed. What is fixed is, if the target is a FIFO, where will you write always? You will always write into the end of the FIFO. Your location itself is end of the FIFO. FIFO internally shifts the data. FIFO internally shifts the data. That is the second category, where address doesn't get incremented. It only keeps shifting the data internally. Okay, we are done with both. Then you may think, what could be the other possibility? Everything we have taken care, right? One is you keep incrementing, one is you write to same location. What is the third possibility? Third possibility is called as wrapping. What is wrapping is, um, it is similar to incrementing. Once you reach a boundary, they again start from the bottom location. That will be called as wrapping. So wrapping is a little concept, difficult concept for today's session. We'll take it in the later part. So for many features, incrementing and wrapping are common, but once you reach the boundary, you come back to the original location, some bottom lower boundary, that is called as wrap. So a burst transfer has how many features, how many possibilities? Three. Not burst type, I'm telling. For a burst transfer, for a master to burst transfer, what all information it has to convey to the slave? Three information. What is the first thing? Burst length. Length means what? How many data phases will be there? See, in the previous example, I showed you one diagram, right? What length it would have told to the slave? 4. Because 4 bits were there. 4 times it was there. So that is important, because slave should know, right, how many times data is going to come. What is second information? Burst size. What is size? How many bytes per beat? Each data transfer, how many bytes will be sent? What is the third one? Burst type. Why burst type is important? Based on that, slave knows how to handle the data. Should I save it into the same location? Should I save it into the incrementing locations? Or should I save it into incrementing? At one point when I reach the boundary, I should come back to lower boundary. That is called as wrap. So master has to convey all this information to the slave. So for that purpose, AXI introduces some signals called as AW burst. It will convey the burst type. Is it fixed? Is it incrementing? Is it wrap? It will convey this information. AW length. What do you think it should be? Length. What is it? Burst length. Number of data transfers. Data transfers. One is AW length. What should be the other one? Burst size. Number of bytes per data transfer. Understand? Per data transfer. The way you break it up is, overall thing is called as transaction. Transaction consists of what? Multiple data transfers. Each data transfer consists of multiple bytes. Okay. AXI supports out of order, overlapping, and interleaved transactions. Three categories: out of order, overlapping, and interleaved transaction. ID signal is required to support all these features. I gave you an example of ID signal. Where did we understood ID example? Home loan in the bank. The same is this. Okay. What is out of order in a bank home loan? What do you mean by out of order in bank home loan? I went today, I applied for a home loan. Today is what? Let's say 14th June. One more person applied on 20 June, but his loan got sanctioned by 25th June. My loan gets getting sanctioned in July. So isn't it happening out of order? Okay, where my request was submitted first, but I got the response last. That is called as out of order. What is overlapping? Same transaction is also overlapping. What is overlapping? While my transaction is in progress, see, my home loan is still processed, right? 15th June to July. They are processing the next transaction also, next home loan also. That is overlapping. Both our transactions are, both of mine and other guys' home loans are overlapping. Okay. Interleaved we'll discuss later. Interleaved means he submits document today, I submit document tomorrow, he again submits document day after tomorrow, I submit after 3 days. Where we are interleaving each of our document submission. We are interleaving the way we are submitting the things, that's called as interleaved transactions. Still bank will be able to identify everything, because when I submit my document, I'll give application number. When the other person submits the document, he also submits application numbers. Let's revise again. What are the types of categories of transactions? Out of order transactions, overlapping transactions. You don't need to remember in the same order. You could remember as interleaved, out of order, overlapping. Okay, don't by heart. Just understand that transactions could happen in 3 possible manners, where they could happen in out of order, where the request is given in one order, response comes in a different order. Overlapping means what? Very simple. While one transaction is in progress, other transaction also initiated. We don't wait for one transaction to complete to do the next transaction. Is APB overlapping in nature? No, right? See, while one transaction is in progress, I mean, only once the APB transaction is done, you do the next transaction. That is non-overlapping. What is interleaved means? The data phases interleaved with each other. At one cycle, one data phase will come. In the next cycle, a different transaction data cycle will come. In the third clock cycle, different transaction data phase will come. They will interleave. Interleaved means what? Tied inside each other. All of these can be possible only because of one concept. What is that one concept? They use a concept of ID. At each stage, everything is identified with the identification mark. Okay, let's read that once. ID signal is required to support all these features. Each transaction is assigned with unique ID. All the phases of transaction happen with that unique ID only. All the phases of transaction happen with that unique ID only. So to support, and other than that, AXI adds signals called as lock, cache, and protection. To support lock transfers, exclusive transactions, it adds lock signal. To support cacheable and bufferable transactions, it uses cache. To support protected and secured transactions, it uses prot. So for different signals, to support different features, they add different signals. So in summary, AXI is nothing but APB plus the new signals that got added. All these signals are implemented using 5 different channels. Okay. Again, I'm telling, don't literally take AXI channels with the TV channels. Concept is what you have to correlate. AXI having channels in the TV is allowing you to watch different programs at same time. Same way in AXI also having different channels allows you to do multiple transactions concurrently. Okay. What is the need for 5 different channels? Let's try to understand. It allows different transactions to happen at the same clock edge. Write transaction is implemented using 3 different channels. What are those channels? Write address channel, write data channel, and write response channel. Read transaction is implemented using 2 different channels, read address channel and read data and response channel. One question will come is, Y3 here, Y2 here. Thing is, they merge these two channels into one. Read data and response channel, you see, write has two different data and response separately. Whereas in read, data and response channels are merged into single channel only. Why they have merged, we'll discuss as we go forward. In case of write transaction, what can happen is, you take this at time 10 nanosecond, what is happening? I'm doing, let's say, transaction A address space is happening. In case of write at the same 10 nanoseconds time, at same 10 nanosecond, for a different transaction, transaction B, write data phase can be happening. Same clock edge. For a different transaction, data phase can be happening. In write response channel, at same 10 nanosecond, transaction C, for a different transaction, write response phases can be happening. Different, at same clock cycle, you could be doing 3 different transaction phases. When we go through the timing diagram, you will understand that. For now, I know I can correlate with you that it's difficult to correlate this diagram, what is happening here. Just right now, remember that we are able to handle 3 different transactions: transaction A, transaction B, transaction C. When you come to read transaction, because read transaction uses a completely different channels. Understand, write is like a different channel, different physical element. Read is like a physical element. So very important thing in AXI is write and read are independent, because there is AW address, AR address. There is a AW length, there is a AR length. There is a AW size, AR size. Every signal is duplicated. Duplicated means, I don't know what is it. 2 sets are there. One set is for write transaction purpose, one set is for read transaction. Because of that, you could be doing write transaction and read transaction completely independent. In APB, is it possible? Not possible. You could only be doing write, or you could only be doing read, not both of them at same point of time. Whereas in AXI, because 2 different channel signal sets are there. You see, like AXI, these sets are there. AWID, AW address, everything starts with AW. Similarly, for read also, there is a separate set is there. ARID, AR address, AR length, AR size. So completely different set of signals are there. Because of that, writes and reads can be done completely independent in case of AXI. So in case of read transaction, at same 10 nanoseconds, transaction D read address space can be happening. And at same 10 nanoseconds, transaction E, I mean some other transaction, okay. Read data phase and read response phase can be happening. How to make all these 5 channels independent? We use, because to make them independent, we use a dedicated handshaking signals for each channel. Each channel we treat it as a separate pipe. So for each pipe, we have separate handshaking signals. So totally 5 pairs of handshaking signals are required. Because there are 5 channels, you need 5 pairs of handshaking signals. Should we use dedicated address signal for write and read or same address? Since AXI protocols write and read transaction to happen concurrently, okay. Each of these channels require their own dedicated signals for everything. Means burst length is specific to write and specific to read. So there is a burst length called as AW length, AR length are 2 different ports. AXI. So one who is initiating write transfer will use what? AW length. The one who is initiating read length will use read transaction will use AR length. Similarly, burst type, AW burst, R burst. Sometimes they'll use the term AX burst. Means X here would mean read and write both of them. For everything, there will be like that. All AXI channels are divided into, AXI signals are divided into 5 different channels. It allows for doing, what is advantage is it allows for doing 5 different transactions concurrently, which results in the improved bandwidth of using AXI protocols. Due to this, the overall bandwidth improves. Let us list down what all signals are required for AXI protocol. Let's start with APB protocol signals. I think it will be probably the repetition of the same activity we did 15 minutes back, but let's quickly redo again. Because there also we listed APB signals, right? You remember we have listed all these things so far. Okay. When you move from APB to HB, P is changed to H. P address will become H address. PW data will become HW data. That's all. See, these signals just change wherever P is there to H. That becomes HB. Along with that, you need to add some more signals. Okay. So AHB protocol adds new signals to support additional features of the AHB. Moving to AXI protocol, signals are classified into 5 different channels further. So here it was very simple. AHB was very simple. Even till AHB, it's only one channel only. APB is one channel. Even AHB is also one channel. So because it's only one channel, since AHB is only one channel, naming convention is uniform. What is meant by uniform? Everywhere they use H address, HW data, HR data, H length, everything is uniform. Okay, there. Whereas when you move to AXI, signals are classified into 5 channels, 5 different channels. For each channel, they have a different starting name. AW, W, B, AR, and R. Means all the signals which fall into the category of write address space start with AW. All the signals that fall into the write data channel will start with what? W. All the signals that fall into write response phase will start with B. All the signals that fall into the read address phase start with AR. All the signals in read data and response phase will start with R. Whereas what about HB? There is no such thing. Everything starts with what? H. In APB, everything starts with P. So here, because we are treating them as 5 different channels, we have a different naming convention for each channel. Tell me, what do you think? For AXI, the handshaking signals are valid and ready. Remember, valid and ready are the handshaking signal. What will be the right response phase valid handshaking signals? What will be the handshaking signals of right response phase? Be valid, be ready. What will be the read address phase handshaking signals? AR valid, AR ready. What will be the right data phase handshaking signals? W valid, W ready. Simple, that's all. Once you know that this signal falls into the corresponding channel, you just have to write that corresponding thing in the beginning. Does it? You may ask next question. Will the data come into every channel? No. Data, in case of write, where do you think data will be present? Which channel data will be present in? Write data channel. So that name will be W data. The name of that signal will be W data. In case of read, in which channel the data will fall into? AR or R? R, right? So the name will be R data. The burst length. Okay. Is it a address phase signal or data phase signal? Burst length, you are conveying how many transfers I'm going to do. That is all address phase information. So it will be AW len. Because it's a control information. You are telling how many transfers you are doing and all that. That all happens in the write address phase only. What about the length corresponding to read? A or len. Simple. Once you know this signal corresponds to this channel, the naming is very simple. Okay. The same thing is discussed. We have added signal specific to support burst length, burst size, ID, burst type, protection, lock, cache, everything. This is how the diagram looks like. Top is what? Write channels, write address channel, write data channel, write response channel. First, let's try to understand the write information only. First, let's only understand the write channels. How many channels are there for write? We will do this and we'll probably end the session. Okay. How many channels are there? Three. From write address will go from where to where? Who will give write address to whom? Master will give to slave. Do you see the direction of the arrow? Where is the direction is from? Master to slave. How many times write address space is done in one transaction? Only once, because that's how the burst transfers work. Write data phase. Who will do to whom? Master to slave. So what is the direction of the arrows in the middle? How many arrows do you see? Four. So what is in this case? What is the burst length? 4. But 4 is not fixed. It can be anywhere from 1 to 16. The protocol supports the burst length of 1 to 16. Now you may say, why 1 to 16? Why not 4? Why not 16? Sometimes you don't want to send a lot of data. You only want to send limited amount of data. So then you need that flexibility. Okay. What is the third one? Write response channel. What is the direction? Slave to master. Because who will give response? Slave. So you can see the direction. How many times response should come? Only once. So that's how you can understand this diagram. See, this is the time axis, time coordinate. First thing, this happens. Once that is done, the next remaining time, this will happen. Once that is done, the write response phase will happen. So that means what? Write transaction consists of write address phase, multiple write data phases, and single response phase. So transaction is nothing but multiple transfers. Let us understand the read channel. Now it will be easy for you to understand the read scenario also. How many channels are there for read? Two channels. Address and control. Read address channel from where to where? Master to slave. Always see whether write or read, address is always given by master. Read data is coming from where? Slave to master. Why it's called as control also? Because you give other information also, like what is the burst length, what is the burst type, what is the burst size. Everything is conveyed during the address phase. This is wrong naming. Ideally I should have used the term address and control. Data channel. Write response channel. Okay. This is what? Read address channel, address and control channel. Because it carries the control information also, not just the address. Burst length, burst type, burst size, cache, protection, lock, everything, whatever we said, right? That all information is carried during the address phase. Okay. Last one is the read data channel. So now, what is AXI transaction? Write transaction is AXI transaction is nothing but request plus response. Write transaction is master gives write address request with address and control information. Slave gives master gives write data request. Write data request. Slave responds with write response In case of read transaction, who gives the read address information? Master. Who gives the read data? Slave gives. This diagram is important. Now this should be clear. All AXI signals are classified into 5 channels. Write address channel starts with what? AW. Write data W. Write response B. Read address AR. Read data R. Some common signals are there. They start with A. Clock and reset. Common clock and reset signals start with A. Means what? A clock, A reset. Because they belong to everyone, they start with A. You know what is handshaking, right? Whatever handshaking you know in APP protocol, same is the handshaking here. Nothing different, absolutely same, right? Handshaking is required. I think I don't have to explain all this thing again. You please read through this once. Only thing you need to know is there are 4 possibilities, right? Both are 0, 1 comma 0, 0 comma 1, 1 comma 1. When do you think the transfer will complete? Both of them are 1 comma 1. So this is when. So this slide is present in the e-learning portal. Please read through that. If you still have a question, get back to me. Because in APB we have discussed in detail what is handshaking, who initiates. Valid is initiated by the master or whoever is doing the phase. Okay. Ready is given by the other component. Let me ask you one question. We'll go to this diagram. Okay. Who gives B valid? B corresponds to whom? Right response phase. Who gives B valid? Slave. So you have to ask B corresponds to whom? Right response. Who will give right response? Slave. So B valid will be given by slave. Who will give B ready? Master. That is important. Valid doesn't always mean master. You need to ask who is initiating that phase. Tell me. AW valid is given by whom? You have to ask AW is what? Right address. Who does right address? Master. Then who will give right address, AW valid? Master. Who will give W ready? W ready. Slave. W ready is the right data. So master will give the right valid. W ready is given by whom? Other side, right? There are only 2 things. If valid is given by one component, ready is given by the other component. Who gives R ready? Who gives R ready? R corresponds to whom? Read data channel. So who is initiates the read data? Slave. Who should give the R ready? Master should give the R ready. Who gives AR valid? Master, because AR valid corresponds to read address channel. So read address channel means it is initiated by master. So valid will be this direction. Ready will be in the opposite direction. Right? So don't think that valid always means master. Ready always means slave. No, that is not correct. You need to see who initiates that part of the channel phase. That is the valid driver. Other component is the slave. One more thing you need to remember is handshaking completion doesn't mean transaction completion. Let's say simple example is you went to a bank, you applied for home loan, you gave the application. There also handshaking happened. Correct, right? You submitted application, he gave acknowledgement also that I have received. Is it handshaking or is it transaction completion? Handshaking. What is transaction completion? When you finally get the sanction letter after going through submission of application, submission of the documents, then finally sanction. That is the uh, whole transaction. So one channel handshaking doesn't indicate the transaction completion. It only tells that, see, handshaking here indicates that read address phase completed successfully. This indicates that read data phase completed successfully. So each channel has a specific significance. So how can I summarize the home loan? My application handshaking should have happened. Data phase handshaking should have happened. I mean, document submission. Sanction phase handshaking should have happened. That is when I can say that overall transaction is complete. Can I say like that? For me to say home loan transaction is complete, when will I say? The application handshaking happened. I have given and he has given me the acknowledgement. Document phase handshaking also should have completed. Where I have given the document, he has given the acknowledgement. Third one, what? Sanction phase handshaking should have also happened. Where he has sanctioned me, I said yes. Let's say at final stage, I say no, I don't want. Transaction is not successful. Right? For transaction to be successful, all the three phases should have happened. Here also same thing. Only when all the things have happened, then only the overall transaction has completed. So we will stop here. Please do read these slides, okay? I mean, to read, these are giving the directions to you. If you see, valid is from where to where. You don't need to really by heart this. Just understand what is the phase. Then you understand the basic concept. Who drives that phase? That is a valid driver, and other component is a ready driver. If you understand that, then you don't need this diagram at all. Okay. In the tomorrow session, we'll talk about these signals in more detail. What is meant by length? Length corresponds to what? Burst length. Size corresponds to burst size. Burst corresponds to burst type. Lock corresponds to lock type. We'll understand the significance of these things and we'll go into deep of AXI. Okay. Any other questions you have? Please come prepared. Make sure that you talk to admin and get the e-learning portal access today itself. And you please go through this. Even otherwise, you can just go to Google and search AXI protocol specification. Very first thing, first or second thing, we'll get this one. You can download and start going through that. Okay. Yeah. Why I'm telling is you should not wait for 1 week time to again just start off. Okay. Otherwise, things move very quickly. When you will realize that by tomorrow's session itself, we'll be starting with some complex things like uh, what is that? Wrapping transactions tomorrow itself, actually. Wrapping transactions and narrow transfers, uh, aligned and unaligned transfers. If you don't come prepared with the basics, you won't understand anything. Okay. We'll end the session.